All right, great. Hey, good morning, everybody. My name is George Karamanoglu. You can call me George K. I'm actually very impressed that you got that in one shot. In any case, I'm the Director of Advanced Business Solutions for Riverbed Technologies, and we're going to be focusing on application performance management, really for the financial services industry. A broad look at application performance requirements, really, from a general perspective. So a little bit about Riverbed, if you're not familiar with us. We've been around for about a decade and a half. Really with a laser focus around application performance issues, which in turn impact the end user experience. And really these issues cover a broad category of problems: operational challenges, network challenges, application compute challenges, again, all which are interrelated and impact our ability to deliver highly performant applications. In that work, we've accumulated 239 application performance specific patents, right? And about 28,000 customers, and we're extremely well represented with just about all of the largest global financial services institutions, as well as their service partners. So, from our perspective, what we're seeing today, relative to really any other time in the last 30 years, is a massive dependency around the application experience or delivery of applications, for the purpose of really enabling this journey towards digital transformation. And the use of a variety of, let's say, technology ecosystems to affect that change, whether it's in how employees interact with their customers, the retail branch experience with integrated multi-channel type of applications, more of an interest or more of a direction towards using cloud technologies, whether that's platform as a services with microservices, or whether that's SaaS-based services, or moving infrastructure and data centers on a wholesale basis into an infrastructure as a service model. We're also seeing the use of Internet of Things to accumulate data, leverage that data, and of course, analyze that data for the purpose of addressing the consumer. So the notion of big data. Now, all these are used in an interrelated fashion. And the key thing that they have in common is really that at the heart of the digital transformation experience is the application. So the emphasis is really on being able to roll out, manage, and deliver applications with the best experience possible. And one of the indicators here that we see that this is actually growing in priority over time is the spend that's going on over the next year. So a 35% increase in the amount of spend towards applications in general, and a 2x increase in the application development staffing that our financial services customers are going through. So from a Riverbed perspective, what this means, this integrated plumbing of application infrastructure means that it's very difficult to tell what the application delivery path is in the first place, or what the components or the dependencies, essentially the blueprint of an application, might be in the first place. So we have this mishmash or spaghetti or hairball mess of application infrastructure, which is tied together, federated in order to deliver a specific experience to an end user. The other thing is, if you think about the rollout cycles and this drive towards innovation, what's being done in the development side is driving this notion of DevOps or agile development practices, which increases the life cycle or the speed of the life cycle at which applications are being delivered and managed in our production environments. And of course, time is money. Latency has a direct impact on financial transactions, application performance, and of course, in order to essentially meet the requirements for a lead in a marketplace with a new innovative technology, we have to get there quickly and first. Now, if you look at the challenges in understanding what the application performance problem might be, we just have to keep in mind that there's a lot going on. There's end user devices, if mobility is of interest, smart tablets, all sorts of devices that need to be supported, network conditions, cloud-based, internal infrastructure, third-party services that need to be engaged, and of course the application is built of traditional application components, legacy environments, and of course new native, cloud-native type of services or APIs that might be called into that application. So where the problem is, really can only be solved through an integrated view of all of this at once with a perspective of, is my application functioning? Is it meeting my financial objectives? Are my end users happy? And if there is a problem, where is the problem occurring? From our perspective, as far as a best practice model to get there, the solution really needs to encompass a complete look of what's going on in the application. Where is it running? What does it consist of? Who are the end users? Where are they located? And being able to relate that to all the operators that have to be marshaled in order to affect that performance. Your IT operations people, the line of business folks, application developers, all need a view in their own language that can be shared across teams in order to know what's going on. And of course, we have to summarize these conditions up for an executive kind of look at the environment. And it does us no good if it doesn't actually tell us something about what's going on with the application and where to actually focus our resources and time in order to resolve a particular issue. So we'll take a look at a simple application example today. Mobile checking, right? Very common, certainly in the retail banking arena or not. There was a presenter just now, which is really indicating that you might have people participating in mobile banking that really weren't in that space before, right? eBay, Google, Facebook are actually announcing banking initiatives. And really, they're using banking APIs and banking partners to affect that. Their focus is on delivering a simple, high-performant, very valuable end-user experience. Here, a very simple application which allows you to deposit using a mobile phone. And by the way, online deposits this past year were the predominant mode of deposits in the financial services industry. So if we look behind that, it might be a very complex environment. Of course, we have our application infrastructure, the various services that are involved, account information, third-party partners, and maybe this is part of a bigger portal, right? So net is a lot of infrastructure to navigate in order to understand how this is working. If we break this down a little bit, we don't have to get too much into the technology, but we essentially have an end user accessing an environment over a network, hitting a presentation layer, let's say, where they're going to get a response. But that presentation layer, in turn, is dependent on downstream services. They might be located in the same data center, or they may have to call out to a third party in order to get some data back. Within each of those tiers, you have different types of technology that are implemented. The network speaks its own language, is implemented in its own mode. And then, of course, the application components have a runtime environment. In some cases, you have access to it, the operating system, the container for the application, and then the application code itself, some of which you have access to, some of which you don't. In some cases, you may not have access to the operating system or the platform. It may just be a service running on the cloud someplace. And that is, in order to understand what's going on, you have to harvest data from each of these layers and essentially stitch a picture together in order to represent the end user experience and the application path and its performance. So we talk about packets, metrics, code instrumentation, et cetera. And again, this is meaningful for each of the operators that needs to understand what's going on. From our perspective, we instrument everything in that application environment. We put it in the right semantics and roll it up in a unified, single, let's say, environment to actually present the analysis back to an end user. We call this the Steel Central Performance Center or Command Center. And again, the idea here is collect all the information you need, either from the end user device, from the application, from the infrastructure, for the network, wherever it might be, analyze it in the right context, deliver up to a common unified user interface, and then put that in the language that the operator needs to see it under. If you're an application operator, tell me about the code, the end user experience, the transactions, the service calls. If you happen to be in the network, tell me about the flows, the conditions on the network, and then, of course, relate that to the application. If you're on the business side, maybe you want to know about financial impact. How much is that degradation in performance going to cost me? So we use a very simple model. Underneath, we identify the resources or the components that you need to analyze. We roll it up, we essentially harvest that data, refine it, store it. We use a big data approach. So from our perspective, we harvest all the data, not just samples of the data, but we want to know everything that happened on the network, everything that happened on the end user device, everything that happened on the application kind of platform, the runtime platform itself. We analyze it, we allow you to visualize, report on it, alert on it, and then we deliver that information to a unified portal where many different types of end users can come in and see what's going on. And of course, this lends itself to third-party integration. And something that you should keep in mind, this is just the visibility side of what Riverbed offers. We also provide a collection of solutions which actually allow you to control the performance. So if we detect that there are issues on the network which are inhibiting the end user experience, we can actually do something about that. Okay, the first piece of this starts with the high-level view. So what do you want to know? Do you want to know how end users are experiencing this application globally in a particular location, or you want to see the application itself in a kind of a unified view of that? So we start with what's called the portal. If we map this to that mobile application, we see that the application may sit on many classes of devices. In some cases, it needs to sit on a container, or let's say kind of an applet, or let's say an iPhone app. In other cases, you have access to the complete device, the desktop, the operating system, and it might be a larger grain application. That's going to go over a myriad set of paths and eventually hit infrastructure which has the application running on it, or the application components running on it, which then deliver that particular application back to that end user. So in this setting, anything could go wrong. The application running on that mobile device could have a problem. Maybe it's impacted by other applications running on the same device. It could be the operating system. It could be the network. The network is impacting your ability to essentially communicate, or it could be something going on in the application itself. Maybe some code that wasn't properly qualified before going into production. So let's start with the first piece, which is the network. We want to look at all of the traffic, all of the communications between that application environment and those end users, and we can do that. We have the ability of essentially tapping the network, collecting the packets, the flows that represent the communications of that application, understanding what type of protocol this is communicating on, dissecting that for the application, and then putting it in perspective so that the network folks understand. But if they detect there's a problem, they can actually communicate in a language that's appropriate for the application team to take responsibility and fix the issue, right? So the network team now has access to understand, hey, is it my problem or is it something else? And can I definitively say what that something else might be? Okay, and of course, the application, protocols, let's say, or applications that are in the mix could be interrelated. It could be market data feeding a trading application, which is communicating by FIX, which in turn is also available by HTTP to somebody's browser if the latency is not necessary. Again, kind of a very complex set of plumbing. So here, using a simple process, we can actually get to the root of the problem. Is it the network? Are we having retransmissions, congestion, delays on the network? And we see that represented by the bars on the bottom. So it's clearly not a network problem in this case. The red kind of area highlights how much time the network or the end user is waiting for an application to respond. So this is telling us that with high probability, the application team needs to take a look at this problem. And which brings up the application. If we look on the application stack, now we need to see what's going on from within the application. The code, the methods, the service calls, the database calls, how is all that behaving in light of the end user experience? So of course, we can sit in the application stack, we can analyze all this behavior, see what end users are coming in, and what we do is we record every transaction that took place. In this case, we have this graph which represents about 10,000 user transactions hitting a particular application environment. It is a financial services application in this case. So again, we collect all the data. These data points are not just plots on a graph, they actually represent some very complex information. For every data point, we actually represent exactly which end user came into this particular application, and then what path did they take through the application. What methods or what application code was instantiated, either on that runtime or outside of that runtime. What database calls were made, what downstream service calls, what APIs were used. All of this is captured, and we actually put it in the perspective of the timeline that that user spent on this particular environment or this particular transaction. But that's not all. For every end user that accesses the system, we actually will provide a breakdown of all the transactional components that were part of that experience and which ones performed the worst, right? Relative to what the normal experience was or to the SLAs that you've set. And each one is unique for every end user. And then, of course, we can also see for every one of these transactions the complete method stack, if you will. So all of the code that executed for that individual end user. And these are not sample-based. If you need to go back in time and you need to say, hey, this particular end user said they were having some problems, let me go back and see if they were having these problems in a similar way last week, we can actually do that without missing any of the detail for that particular transaction. And the other thing that this allows us to do is once we see that there's a problem, we can actually add information into that particular transaction. Say this one is actually very expensive when it happens. Maybe it's $10,000 an hour, maybe it's $1 million a minute, whatever it might be, but you can actually add that context in. And now when the system tells you that something is going on, it's actually going to factor that in, try to roll up financial impact and actually relate that to the business as well. The final piece of this is the end user. And in many cases, the end user experience is really what we're after the most. If we can't get a good end user experience, adoption, the utility of the application, the investment, all kind of goes away. It all vanishes. So in this case, we need to understand, and in some cases, something that's very difficult to understand if you can't get to a device. An iPhone device essentially locked up. All you have access to are the applications that somebody installed on that iPhone. We can actually instrument that. If you have, so let's say, more open access, you have an employee with a company-issued laptop, and you want to know about all the critical applications that are installed there and whether they're inhibiting a particular workflow, a business activity, the support of an end user or a customer, we can actually tell that. Not just by transaction, but by workflows, by activity, meaningful business conditions in that application. And the way that we do that is we can actually instrument many types of clients, right? Certainly the operating system or the client operating system, but also the containers, the runtimes, the languages that these applications speak, regardless of what they might be. If you have a corporate standard which says, hey, I have this great new application, but it has to be delivered by VDI, we can actually make sense of that. If it's a new application, it's only going to be deployed as an applet, let's say, or as an app on a mobile device, we can actually instrument that. Okay? And what you get here is, if there is a problem, or you just want to understand, is the performance increased? I delivered a new version. It's supposed to function better. Do I have a baseline of the before and after picture? You can actually identify that return by a specific end user. What's going on from that end user's perspective? What are they accessing? Is there a problem? Or are they actually doing really well? If you do have a problem, you want to relate that to other people in the, let's say, in the organization or other users. And of course, we can do that. We can say, who else is experiencing a problem like this without the problem having to be exactly the same, right? Is it similar in scope, similar in degradation, right? And is it contained to a particular geography, a particular subsystem of the application, or is it unique to this individual? And what is the probable cause? From the end user's perspective, because we're actually sitting on the end user's device or on the end user's application, we can determine, is the wait time on the network, or is it somewhere further downstream? And then we can corroborate that based on what the network visibility tells us, or what the application internals visibility tells us. So the benefits here are across the board. The line of business gets the insights to know that their investment is paying off, that the end users are being engaged with the right experience, and what the impact, the financial impact is for these applications, whether it's good or bad, right? From a design and development perspective, you now have the ability to actually incorporate these insights in the development process and share them with the production teams. So whatever you learned in testing and QA and stress testing, whatever it might be, can actually be used as a baseline for folks that are then monitoring the system in production, where it changes very dramatically. Very difficult to reproduce a production environment in a test environment, but it is very useful to share those two sources of information. And of course, from an IT operations perspective, to make sure that you have faster response, a pinpointing of resources that are needed in order to resolve a problem, and much faster, much more agile operational capabilities in deploying, running, and maintaining these applications. If we look across the board from kind of our financial services folks, we see some significant benefits. Increased performance, less errors, faster operations, even the elimination of workflows altogether, right? So a better margin overall on the application experience. I will leave you with this one message. Visibility is certainly a key aspect of what Riverbed provides, but we also give you the ability to control and improve on the delivery of those applications as well, with a platform or a family of solutions focused on this problem. Thank you very much. Please visit us at the Teneo Riverbed booth.